All right, lesson 3-4 is the polygon angle sum theorems, and our objectives are to classify polygons and find the sums of the measures of the interior angles and exterior angles of polygons. So first, let's look at our vocabulary and key concepts. Theorem 3.9 is the polygon angle sum theorem. We used the triangle angle sum theorem in a previous lesson. Now we're on the polygon angle sum theorem. The sum of the measures of the angles in an n-gon, n just means however many sides it has, that number goes there, is n minus 2 times 180. So n is just the number of sides on a polygon. So then, looking at the exterior angles, theorem 3.10 is the polygon exterior angle sum theorem. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So looking here, we've got 5 exterior angles in this picture. If you add them all up, it's going to equal 360 degrees every time. All right, then we've got some vocabulary. A polygon is a closed, that's important, closed plane figure. So it can't be open, it has to be closed. Closed plane figure with at least 3 sides. Can't form a shape unless you have at least 3 sides that are segments, so they can't be curved. They have to be line segments. And sides that intersect only at endpoints. So the sides can't intersect somewhere in the middle. All right, so then if we're looking at these examples, this first one is a polygon because it's got straight segment sides, it's not open, and it doesn't intersect anywhere. The second one is not a polygon because it's not a closed figure. It has that one side open right here. Okay, this third one is not a polygon because 2 sides intersect between endpoints right here. So if that clears up what a polygon is. Then we've got a convex polygon. A convex polygon does not have diagonals with endpoints, or with any points, sorry, outside the polygon. I like to think of it as no sides cave in. All the sides are straight. That's just my way of thinking about it. I think it makes it a little simpler. So like here, they're drawing all the diagonals from every point. None of them end up outside of the actual shape. So this is a convex polygon. Then a concave polygon has at least one diagonal with a point outside the circle. Or sorry, outside the polygon. And I think of this as one side caves in. So right here, when they drew these 2 diagonals, those are outside of the shape. So this is a concave polygon. these sides right here cave in. That's how I think about it. Okay, couple more terms here. We've got an equilateral polygon has all sides congruent. Remember, an equilateral triangle had all the same length sides. Equilateral means all the sides are the same. An equiangular polygon has all angles congruent. Okay, remember, equiangular means equal angles. And a regular polygon is both equilateral, so all the sides are the same, and equiangular, so all the angles are the same as well. Okay, now we can jump into some examples using what we've learned. So, example 1, applying polygons. Classify the polygon at the right by its sides. Identify it as convex or concave. So, before we get started on the example, we're going to jump back up here and make a quick note so that we know how to classify polygons by their side lengths. Okay, so each number has its own prefix that we use for the number of sides. So 3, we call it a triangle if it has 3 sides. 4 is a quad. This quad means 4, quadrilateral. If it has 5 sides, we call it a pentagon. Some of these you guys will know, some of them might be new. If it has 6 sides, we call it a hexagon. 7 sides is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 11 is an undecagon. 12 is a dodecagon. 13 and up, everything after this, they just call it an n-gon. So if we had a 14-sided figure, we call it a 14-gon. Okay, so everything after 13 is 13-gon, 14-gon, 15-gon. They quit making up names after that. Okay, so that's important to know when we're naming shapes. So, starting with any side, count the number of sides clockwise around the figure. So we're going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the polygon has 12 sides, so it is a dodecagon. Dodec meaning 12. Okay, think of this polygon as a star. Draw a diagonal connecting 2 adjacent points on the star. So we're just going to connect 2 points. So if I connect from this point to this point, that's a diagonal between 2 adjacent sides. The diagonal lies outside of the polygon. So the dodecagon is concave because the sides cave in. Finding a polygon angle sum. Find the sum of the measures of the angles of a decagon. Remember, a decagon has 10 sides, so n equals 10. We know by the polygon angle sum theorem that n minus 2 times 180 gets us the sum of all the angles. So we know that n is 10, so we're going to substitute 10 for n. 10 minus 2 is 8. And then if we do 180 times 8, we get 1,440. So the sum of the angles in a decagon is 1,440 degrees. Number 3, using the polygon angle sum theorem, find the measure of angle x in a quadrilateral XYZW. The figure has 4 sides, so we know n is 4. Okay, and we know if we solve this out, 4 minus 2 times 180. 4 minus 2 is 2. 180 times 2 is 360. So we know if we add them up, it has to add to 360 by the Polygon angle sum theorem. Then it tells us Z is a 90-degree angle, W is 100. And it still adds up to 360. If we add those together, 100 plus 90 is 190. Then if we subtract 190 from each side, we know that x plus y has to be 170 degrees. Well, this little mark here means that these two are the same, so it's just like adding the measure of angle x twice. So it still has to add to 170. This is the same as saying 2 times the measure of angle x equals 170. So then, we substituted the measure of angle x for angle y. So then we know it's 2 times the measure of angle x equals 170. If we divide both sides by 2, we know that x has to be 85 degrees. Okay, so this Polygon angle sum theorem really takes care of a lot of problems for us. All right, we've got one more example to look at. Applying Theorem 310. This says a regular hexagon is inscribed in a rectangle. Explain how you know that all the angles labeled 1 have equal measures. A hexagon is regular. The hexagon is regular. We know regular means all the angles are the same, all the sides are the same. So all its angles are equal, and exterior angle is the supplement of a polygon's angle because they are adjacent angles. So like here, this angle is the interior angle. All the interior angles are the same. Angle 1 is the supplement to that angle. Because supplements of congruent angles are congruent, right? All these angles are the same. So if angle 1 is the supplement to this angle down here, it's also the same supplement here. All the angles marked 1 have equal measure. Okay, then we've got some check for understanding problems for you to try out. The first one says, classify the polygon by its sides. So sides first, and then decide if it's convex or concave. 2 says, find the sum of the measures of a 13gon. So n equals 13. Part B, the sum of the measures of the angles given is 720. Use the Polygon angle sum theorem to figure out how many sides it has. So instead of knowing what n is, we know the answer is 720 equals n minus 2 times 180. And you need to solve that. All right. 3 says pentagon ABCDE has 5 congruent angles. Find the measure of each angle. So use the Polygon angle sum theorem. Then if all 5 angles are congruent, divide that by 5 to get your answer. And finally, use the figure from example 4 to find the measure of angle 2. Then is angle 2 an exterior angle? Okay, so if we're looking at this picture, I would first find the measure of the interior angles using the Polygon angle sum theorem. Then you'd be able to subtract that from 180 to find angle 1. Then you would have 2 sides of this triangle, and you could find 2 pretty easily. Okay, so go ahead and get started on these check for understanding problems. If you have any questions, make sure you're letting me know.